Okay, this is 4445, problem number 30. We have a clock that has a 4-inch minute hand. So this side over here is 4 inches, and a 3-inch hour hand. So this is 3 inches. And we want to know how fast the distance between the tips of the hands is changing. Well, the distance between the tips of the hands would be this segment right here going to the tip. And we're going to call that C, little c. So capital C in here is going to be the angle C. So we want to know how fast this tip is changing. So we are looking for d little c dt is what we're looking for. And we got to figure out how these three things, these all relate to each other. Well, this angle is going to be greater than 90. So you got to know remember back to geometry that when you have a non-right triangle, SOHCAHTOA doesn't work for a non-right triangle. So we had law of sines and law of cosines. So since we have two of the sides and dealing with the angle between and the side opposite, we use law of cosines. So I'm going to write the law of cosines form equation down from geometry, which is c squared, that's little c, this side over here, is equal to a squared plus b squared. It kind of starts like Pythagorean theorem. And then it's minus 2ab cosine of angle C. This is that angle right there between the big hand and the little hand. So what we know is this, I'm going to call this A. I'm going to call this the B. And these hands don't change size. So since these hands don't change size, they're always 4 inches and 3 inches, we can plug those into the formula right now. Let's see, 3 squared minus 2. Now, angle C is going to change because the minute hand's moving closer to the hour hand all the time, and so these tips are changing all the time. So we got to keep these variables. So I'm going to go ahead and simplify this thing down a little bit. 4 squared is 16, 3 squared is 9, so this is 25. And then 8 times 3, 2 times 4 is 8 times 3 is 24, cosine C. You cannot combine these two because they're not like terms because this cosine C is different. So we're going to take the derivative of this function right here, and then that's going to give us the dc dt right here with this part. So let's say all the stuff we know. So we're going to get 2c dc dt, and this is little c. This is what we're looking for. Derivative of 25 is 0. The derivative of this is negative 24. And then we got to do the derivative of cosine is the outside part first, which is negative sine c. And then the angle of c dt, because we're doing c with respect to time. So we need to find what little c is. We need to find what angle c is. And we need to find what the rate of change of angle C is at the time these are at 4 o'clock, because it wants to find it at 4 o'clock. So we're supposed to know that all the way around a circle is 360 degrees, which is 2 pi. Okay, so that's 2 pi. And the minute hand goes around 2 pi in 1 hour. So 1 hour. So the minute hand, the rate of change in the minute hand is 2 pi per hour. The rate of change of the hour hand is the hour hand goes all the way around the circle in 12 hours. So that's going to be 2 pi divided by 12 hours. So this would reduce to 1 pi over 6 per hour. If you reduce this 1 pi over 6 per hour. Now you could just put pi over 6 hours and put the h there. That is the same story, so it doesn't really matter how you do that. Okay, so what we need to do is figure out what the little c is too. We need to find little c. Well, let's find the angle. Let's find the angle between what angle C is exactly at 4 o'clock. We want to find this angle right here at 4 o'clock. So at 4 o'clock, we need to find angle C. Okay, so we're going to use what we know about how far it is between each minute. So each minute, this thing goes around 60 minutes, right? 60 minutes, the minute hand travels around 2 pi per 1 hour, which is 2 pi for 60 minutes, which ends up being pi 30ths per minute, radians per minute. Okay, so this is pi, now that's every minute is going to be that much, pi 30th. So we have, from here we got 20 minutes. So from here to here, that's going to be 20 pi per 30 minutes, which is 2 pi over 3, which is also 120 degrees. So we could use 120 degrees, or we could use 2 pi over 3. But we want to find this C value. So in other words, angle C is 120 degrees or 2 pi over 3 radians. Either one of those is fine. So to find little c, we plug that into this formula right here. So c squared is going to be 25 minus 24 times the cosine of 120 degrees. Now if I do 120 degrees, I can use the unit circle to find what the cosine is. So 120 degrees is right up here. And your ordered pair right up there is -1/2 and positive radical 3 over 2. So that means this is the x value, -1/2. So this is going to be 25 minus 24 times -1/2. So c squared is going to equal 25 plus 12. So c squared is going to equal the, I should say 37. Getting ahead of myself. So c is going to equal positive or negative square root of 37. Well, we don't ever want it to be a negative, so square root of 37 is c. So we now have the angle, and we have the little c to plug into this thing. So this is going to be 2 times the square root of 37. This is the thing we're looking for, dc dt. Over here we got -24. Actually, I'm going to take negative times negative and make that positive 24 sine of 120 degrees. And now the hardest part is finding this change in angle C. So I'm going to go ahead and plug that in here in a minute. But we need to take into consideration about these two things we talked about. So in other words, as this hand is moving this way, this hand is also moving this way. So we need to get the rate of change of dc dt. Well, the minute hand is moving faster. It's moving at 2 pi per hour. So it's getting closer. The distance of this is getting closer to this as this one moves around pi 6. So the way this angle is moving is, this one's moving slower, so it's going to be pi 6. It's going to be pi 6 minus 2 pi, because this thing is moving faster. This distance is getting shorter. So if I get a common denominator here by multiplying this thing by 6 over 6, that gives me 12 pi over 6, which gives me -11 pi over 6. In other words, this distance right here is getting shorter by that much per hour. So we're going to put over here -11 pi over 6. And I probably should have gone on up here, but we're going to do this now. This is radical 3 over 2 is a sine of 120. So I'm going to stick that in there, and then I'm going to go ahead and solve this thing for dc. That's little c dt. So this is radical 3 over 2. And this is still -11 pi over 6. So I'm going to go ahead and reduce these two. So this is 12. Now reduce this and this to 2. So we're going to end up having dc dt is going to equal, let's see, we got We got 2 times radical 3 times 11, negative 11 pi, right? All over 2 radical 37. So I would probably go ahead and reduce these at the same time. And so the rate of change, if you remember the clock, the length of the clocks are in inches, and we are doing per hour up here, so that'd be per hour. So that would be what we're looking for. If you type that in your calculator, it should be about negative 9.840 inches per hour. So that's how the distance is changing between the minute hand. We're talking about the distance between here and here is changing right at 4 o'clock. And it is getting that much closer at the time of 4 p.m. or 4 a.m. on the clock. So pretty hard problem. See you later.